Welcome to the Lab 2, a video for my classroom. Myself G G Bhide from Finolex Academy Ratnagiri is going to deliver a video on Finite Element Method and Introduction. These are the contents. You can go through this. FEM Basics, Discretization of Two-Dimensional Problem, Shape Functions and Element Coefficient Matrix, Shape Function Calculations, Element Coefficient Matrix Calculations, Global Coefficient Matrix, and summary. In this slide, you can observe one sketch resembling a stress or truss type problem with which we can learn the FEM basics like elements, element numbers, local node numbers, and global node numbers. Let me explain them one by one. In finite element method, there are different types of elements such as line segments, 3-node triangles, 6-node triangles, quadrilaterals, etc. I have used 3-node triangles as you see over here. In this sketch, there are total 26 triangular elements whose numbers are written in the encircled form within the elements. The local node numbers are always written inside the element and assigned in anti-clockwise fashion. The global node numbers are written usually outside the elements and except for the interior nodes, for example node number 11, 14, 15, 16, 17 and 20. Thus there are total 22 global nodes from 1 to 22. In this slide, we have the formulae for shape functions for a triangular element which are called as alpha 1, alpha 2 and alpha 3. The derivation is not covered here, but the formulas are in a cyclic form as alpha 1 is equal to 1 over 2 times area of the triangle x2 y3 minus x3 y2 plus y2 minus y3 into x plus x3 minus x2 into y. Similarly for alpha 2 and alpha 3. The area of the triangle can be computed by using this formula. One interesting property can be noted about these shape functions in the next slide. Before that, we learn the general term from the element coefficient matrix called as Cij of E, which is given as integration of gradient of alpha I dot product with gradient of alpha j over the area of the triangle ds. So here, for example, I have considered the term as C12 from the element coefficient matrix, which is computed by using this formula, obviously derived from the above formula. So the gradient of alpha I comes out to be y2 minus y3 x cap plus x3 minus x2 ay cap dotted with 1 upon 2a y3 minus y1 x cap plus x1 minus x3 ay cap. Finally, we arrive at the formula C12 of E as 1 upon 4a y2 minus y3 into y3 minus y1 plus x3 minus x2 into x1 minus x3. These are the sample calculations for shape functions. The coordinates for x1, y1, x2, y2 and x3, y3 are taken as 3, 5, 1, 2 and 6, 4, and the values obtained are 1.5 over 11, 9 over 11 and 0.5 over 11, and the summation of alpha 1, alpha 2 and alpha 3 comes out to be unity, and this can be tested for any coordinate. That means you can choose the value of x and y as per your choice, but every time you will find that the summation is always unity. This slide shows the calculations for element coefficient matrix. As per the previous slide, I have computed all the 9 terms from that element coefficient matrix, which are shown over here as 29 over 22, minus 13 upon 22, minus 16 upon 22 and so on. If you observe carefully, you will find that the summation of all the terms in one row comes out to be 0. 29 minus 13 minus 16, that is 0. And if you add the terms in the column also, the sum is 0. That's why the comment is written as summation of all the elements in any row or column is 0. Now let us understand the formation of global coefficient matrix, for which I have selected a two-dimensional FEM mesh consisting of 3 elements 1, 2 and 3, and they are connected in such a manner that there are total 5 global nodes, number as 1, 2, 3, 4, 5. So here the size of the global coefficient matrix will be of 5 by 5 because it is decided by the number of global nodes. So if we have, let us say, 7 global nodes, then the size of the matrix would be 7 by 7. Now let us understand how the global coefficient matrix terms are determined. Let us, for example, discuss this second term, that is C12 of that global coefficient matrix. It means I have to find out what is the relation of global node number 2 with itself. So here I find that global node number 2 is connected with element number 1, element number 2 and element number 3 through the local nodes as 3 from element number 1, 1 from element number 2 and 2 of element number 3, and therefore what I find is that the terms are C33 of 1 plus C11 of 2 and C22 of 3. Let us take one more example. Suppose I want to find out C55, then I come to know that the global node number 5 is connected with element number 3 through local node number 3, hence the term appears as C33 of 3. Let us take one more example as a mutual term, C24. C24 means this term. So C24 is global node number 2 is connected with global node number 4 via element number 2 and element number 3. As you observe over here, the link is from local node number 1 to local node number 2 of element number 2. Therefore this term is there, C12 of 2, and another term that contributes is C21 of 3. So in this way we can find out all the 25 terms from the global coefficient matrix. Let us summarize as element numbers and local node numbers are written within the element. Global node numbers are written usually outside the element except for the interior global nodes. The properties of element coefficient matrix and global coefficient matrix are as following. The sum of terms in any row or column is always 0. These matrices have symmetry property. C12 is equal to C21, for example. The self terms like C11, C22, etc. are always positive. The self terms of global coefficient matrix are made up of only self terms from element coefficient matrices. The mutual terms of global coefficient matrix are made up of only mutual terms from element coefficient matrix. Let us go back and verify this fact. As you observe over here, these are the self terms which are there in the diagonal. C22 of 1, C33 of 1 plus C11 of 2 plus C22 of 3 and so on. So not a single term is of the kind C12 or C23 will appear in the diagonal. On the contrary, the mutual terms are never containing the self terms. They are like C23, C21, C21, C31, etc. So in this way we can learn the basics of global coefficient matrix. Thank you.